So either how have you changed or improved as a person during this time, or how have you made the most out of this time at home? You can take a minute and answer that question in the chat there for your responses. We'll go ahead and get started. This is lesson number 36, converting parametrics. So last class we did our intro on how to graph parametrics, right? Introducing what the parameter t is. We said the end goal. We'll do that word problem with the baseball being hit, and we'll get to that probably 2 classes or next class. Yeah. Here's where we're at in the calendar right now. Crazy, we're getting close to the end. Today is the 29th. Converting parametrics is what we're looking at today. Then tomorrow, Zoom office hours. Friday, no school. Next week, we're going to continue. We're going to do the word problems of parametrics Monday and Tuesday. And then we'll close out with our last unit, which is polar equations. And then your AP exam starts the following week. And so that's just going to be a review time. No new lessons there. So I was thinking maybe we should have like some sort of last class, non-lesson related, but I don't know, like maybe like doing some kind of I don't know if you can do an online game or something like that, just to close out the year. It's been a year, quite a year. One quick grading update, and this is a significant change. I received the information yesterday that it's formal. So DIC is switching to 1 grade a week now. So it's no longer 2 grades per week. So really by the end of the 6 weeks, you only have 6 grades, which is crazy because that's very little amount of grades. But that is the new policy. And so just heads up, that's going to be across the board for all your classes. And so for me, for my class, I think I already have 3 grades up, but I hadn't even graded last week's work. Yeah, I hadn't even graded last week's work, and I was about to grade it, and then I got the email. And so what I'll probably do, since I have 3 grades in already, first off, if you haven't done those, it's important that you do those, because that is, you have such a few amount of grades, so every grade will count and affect your grade a lot, right? So, so because I think I have 3 grades up, I really want to have 3 more grades to put in, and so I'm just gonna pick 3 assignments at random from either last week or this week or next week. I'll decide that. Keep you on your toes so that you know that you're doing all the assignments. I'll just pick 3 random last ones, and that'll be the ones that will be your last 3 there. Okay. If you have any concerns with respect to your grade not being what you want it to be, I'll try to think about, if necessary, providing opportunity for extra credit. But the assignments generally are not difficult, and I provide opportunity to answer questions in Zoom office hours if you need that. So any questions on the grading update or the calendar? All right. If there are no questions, we'll go ahead and get started. As always, we say our 4 goals. We will learn math, build character, never give up, and ask why. All right, so let's jump into it. So we're talking about how to convert parametrics today. So last class we introduced what is a parametric equation, and that is the one on the right where you have 2 equations, one with x with relationship to t, and one with y with relationship to t, t being that parameter. So in the case we looked at last class, it was if a ball was in the air, t was the parameter of time, and depending on where that time was, you can see positionally, horizontally and vertically, where the position of the ball is in the air. And so you have 3 variables there. You have t, which is the parameter of time. Then we had x and y, which is the position of the ball horizontally and vertically. So parametric equation allows you to introduce the relationship between 2 variables with respect to a parameter, which more often than not is time, but it could be other things. Rectangular form is what we're used to, which is just the relationship between y and x, so standard coordinate plane. So that what we're looking at is how would you convert a parametric to a rectangular form. Okay, that's the lesson for today. So let's first just go ahead and graph this first example that we have here based on what we learned. So if we have this, I spelled this wrong, my typos. parametric equation. So if we want to graph this and we have this interval, remember we would start with the lowest interval, start with -2, -1, 0, 1, and 2. We will plug in for x and y, find what those values are, and then graph it on here. So I'm gonna give you a minute to do that. And you can send a message in the chat when you're done with that part.
For -2, for x I got -3, for y I got 3. Next one I got -2, and for y I got -3. Next one I got -1, and for y I got -5. Next I got 0 and -3. Next 1 and 3.
Okay. So let me just graph those. -3, 3, t equals -2. -2, -3. And keep in mind when you graph a parametrics, you do want to include the parameter t equals on the graph for each point. And then when you connect them, keep in mind that you're supposed to add the direction component, like so. All right, very good. So what we notice when we graph it is that it creates a parabola, right? And so what we're looking at, how would you write the equation of that parabola in rectangular form? So rectangular form being y and x. So if you were just to write this equation of this parabola in standard form, it would be y equals what? So in order to do that, what we would do is our steps would be first you solve for t in either of the parametric equations. Now for this case, it's better if we solve for t for the x equation because it's written more simply. So we're gonna do that over here. X equals t minus 1. So we're gonna solve for t. It's gonna add 1. We're gonna get t equals x plus 1. The reason that we want to solve for t is because then we can use substitution. And in order to eliminate the variable t, because if t equals x plus 1, we can substitute in the second equation for t, x plus 1, which will then eliminate the variable t, and you'll be left with only y and x. So it'd be like y equals 2, but then in place of t, we're going to put x plus 1 squared minus 5. So we solve for t first, and then we substituted that into the other equation. And then we can solve. Now, we can just look at this, and we can do a quick check. This is now in what form right here? What form of a quadratic is that, thinking back? There's a name, the form of that equation.
Vertex form?
Yeah, that's vertex form, right? Because vertex form is a parentheses x minus h squared plus k, where h and k is your vertex. You can think about it based on transformations as well. Like let's think this is the original quadratic. This means it moved left 1. This means it moved down 5. So if you think about left 1, down 5, our vertex is right there. This 2 is a vertical stretch. And that means it goes over 1 and up 2. It's been stretched, and that's the case. So you see how that matches. So that's how you get the rectangular form of the quadratic. Now let's convert that to standard form. So we just write this out. 2 and then x plus 1 twice, and just kind of distribute that and simplify it just to see the standard form as well. But that's really all. So I'm going to distribute this 2 first, just to deal with it. And then you can use FOIL or box. So I'm going to do this. It's 2x squared plus 2x plus 2x plus 2 minus 5. Combine like terms. These two combine to give us 4x These two combine to give us -3, and this is going to be the standard form of the quadratic. All right. Any questions on that part so far? So just converting from parametric to rectangular, you solve for t in one of them, substituted in the other equation for t, you get y and x related to one another, which is the graph of the parametric in rectangular form. Any questions on that? All right. Thanks for the thumbs up, Jimena. I guess we're good. All right, let's look at another example. We'll do one more together, and then I want you to try one. What is the rectangular form for the curve given by the parametric equations x equals t squared plus 5t minus 1 and y equals t plus 1? So in this case, if you notice here, the answer choices are written as x equals and then the expression. So what that means is that you need to substitute the y equation into the x equation, right? Because you want this x to remain on the left side by itself, so you want to substitute in for here and here, so that it's just x equals, and then you get your expression there. So we're gonna solve this one instead this time. Wait, let me do that. That's not enough space. Y equals t plus 1. We're gonna solve that one. Subtract 1, so you get t equals y minus 1, so that you can substitute this right here for t. Let me get this out. So I'm gonna substitute that in like so for t. Because when you simplify all of this, you're gonna end up with one of these answer choices. So we're gonna have x equals, I'm gonna square this. So write it out twice. I'm gonna distribute this by y minus 5, bring that down. And we're gonna go ahead and FOIL or box method this. It's y squared, y times -1, -1y, -1 times y, -1y. This is just the algebra part. -1 times -1 plus 1. Bring everything down. Combine like terms there. So combine this, this, and this. That'll be 5 minus 2, 3y. We can combine 1 and -1 and -5. That will make -5. We can bring down this y squared. And so that would be the rectangular form. That's showing the relationship between x and y. So that would be D. Now, before we get to part B, I want us to think about something and stretch our thinking a little bit. If you were to graph this, what would it look like? Think about it. Me.
Wouldn't it be like,
Very good. Why would it be sideways?
I don't know, because the X and Y are backwards?
Okay. Let's build off of what Natalia says. The X and Y are backwards, so therefore it would be side. So she's saying it would be like this. Okay, so Y, would it be like that? I'm just gonna graph it while you're thinking. Y squared, where's Y on here? Minus 5. Oh, this is the Y. Oh, what happened? Dang it. Man, I'm having trouble on here. Okay, x equals y squared. What is it? Plus 3y minus 5. Okay, so you see how it's sideways, right? So why would it? So you're right. Kelly said it's quadratic, and then Natalia said it's going to be sideways. And so why is it sideways? Thinking about it, take our step deeper there. And this is not a function, right? Because if you do the vertical line test, it's not a function. So if you think about let me help us out a little bit here. If you think about the standard form of a quadratic, it's like this: ax squared plus bx plus c. Or if you had an example, it'd be like that, right? That's an example of a standard form. This is in that form, however, x and y are switched, right? What do we know about when x and y are switched? What does that mean?
It's the inverse.
Mm-hmm. And so if you think about it from that perspective, if you remember, if you have a quadratic, whenever we found the inverse of a quadratic, it reflected over that diagonal line, and then it created two square roots, if you remember. One was positive, one was negative. And when we restrict the domain, we got one or the other. So just by switching the x and the y, you're going to get this kind of parabola sideways. So that's why this, when it's x equals y squared in standard form, instead of y equals, it creates that sideways parabola because x and y are switched. And so therefore, when you're plugging in for y as your input, you can get different outputs for your x. So it's kind of backwards. So that's why it's going to be sideways. Just wanted to kind of explore that a little bit. Very good. Okay. So does the point 5 comma 3, we're on the next part now. Does a point 5 comma 3 pass through the parametric graph? So we can do that one of two ways. We could graph it like I just did, and we can look at it and see, okay, 5, 3, 1, 2, 3, 4, 5. 3, does it pass through? You can kind of look at it visually. But what if we didn't have the graph? What would we do in order to see if it passed through?
Can't we just plug in the points to see if we get the other point?
Okay, and where would we be plugging this in?
Into the rectangular equation.
Very good, yes. We're gonna plug this in here. That's the easiest place to plug it in. We could plug it into the other one. We'll talk about that in a minute. Let's plug it into the rectangular here. So 3, no, that's not 3. X 5 equals x or y is 3, so 3 squared plus 3 times 3 minus 5. So we just plugged in x and y. The 5 in for x, the 3 in for y. 5 equals 9 plus 9 minus 5. So 5 equals 18 minus 5. So 5 equals 13. Is that a true statement? It is not, right? And so because it's not true, that means no, it does not pass through the parametric graph. Okay. Another way we could do it, we could plug it into these equations up here. If we plugged it into those equations up there, we would plug in 3 for y here. And so you get 3 equals t plus 1. And you solve for t. You get t equals 2. And you would plug in 5 for x here. So you get 5 equals t squared plus 5t minus 1. And you would have to solve for t here, so you'd move the 5 over, so you can factor because it's quadratic. So it'd be 0 equals t squared plus 5t minus 6. And when you factor that, you're going to get 0 equals t plus 6 and t minus 1. And when you solve that, you get t equals negative 6 and t equals 1. And so if you plug in for x and y and solve for t, what has to happen if it passes through that point is that this t has to match with the t over there, right? Because If you're talking about the point in which x and y is the same, the t, which is the parameter, has to remain the same. And so if they're not the same, then you know they're not passing through. So you can plug it into the parametric for x and y, solve for t. T has to be equivalent, or you can plug it in for rectangular if you have the rectangular and see if your answers are equivalent. So that's how you would tell if a point passes through without graphing. Okay. All right. Very good. Let's try one more. I want you to try this one. Actually yourself. So go ahead and take a minute to try this one. There's about 3 or 4 ways you could do it. I want you to pick whichever way you think and try that method. Okay. Who did finish? Can someone tell me what you did here if you got the answer? Hello, can y'all hear me?
I plugged in the 4 and 7 into x and y for each one
Okay.
to see which one, and then whatever I got, I solved for the slope to see if it matched.
Okay. So which one worked?
C.
C. Okay. So let me see. So you plugged in 4 for x. So 4 equals t plus 4. And you plug 7 in for y. 7 equals 3t plus 7. And you solve for t.
Yes.
This is t equals 0. Divided by 3, that's also t equals 0. Okay, and so you said because the t's were the same, therefore it's that. Is that why it's that one? Or you said something about the slope? I didn't understand.
Yeah, because I tried this one because the t were the same. I tried to solve for the slope to see if it matched up with that. So like I plugged in, I solved for t in the x equation, which got me x minus 4, and I plugged that into the y.
Okay. That's important. That's important to note, because if you solve for t in A, like let's say I plug in 4 equals t minus 4, I plug in 7 equals 3t plus 7. When you solve this one, wait, never mind. No, hold on. No, it wasn't A. Wait, never mind. Ignore what I just said. Okay, so you plugged in. So you solve for C. So you subtract 4. And you plug that in for T, right? So you plug this in here, so you get y equals. Hold on 1 second. Oh, my bad. Say hi, Zane.
Hi, y'all.
Say hi. Oh, you're saying hi. Thank you. You gonna teach? Uh-oh. Oh no, what'd you do? Okay, go with mommy, all right? Yeah. Okay. So after you solve for t, you got x minus 4. And you plug that in for this one right here, right?
Yeah.
Okay. And then you get y equals 3x minus 12 plus 7. And then that gives you negative 4. Okay, and then you saw that this was slope-intercept form, and this is the slope, right?
Yes, and it's -5.
Thank you. Okay, very good. Yes, so that would be a way you could do it, and then you could determine a C. Another way you could also do it, if you take note here that your slope is 3 and it passes through this point, you could use point slope form. If you remember, we talked about that last time. Y minus y1 equals m times x minus x1. And then you could say, okay, it's y minus y1 is 7, m is 3, x minus x1 is 4. And you could distribute this. You get 3x minus 12. You can move the 7 over, and you get 3x plus, or 3x minus 5. And then what you could do with this, just another method if you didn't want to plug in, you can then convert each of these to rectangular form and compare with that and see if it matches. So that's just another way you can also do it. So either way you do it, you will get C. All right, very good. Okay, let's look at one more and then we'll be done for today. So we kind of intro this and talk about this last class. If you remember, we had a case in which we graphed this parametric equations, and then we ended up with an ellipse, and we talked about briefly why. In your notes, if you printed the notes, it just says for sine of theta. I want you to add a -1 at the end, just because I want to do an example where you have a number as well. So take a minute to add that. So if you remember, when we're converting this to rectangular form, and so this theta should actually be a t here since we're talking about parametrics. So this is a t. So we have x equals 2 cosine of t and y equals 4 sine of t minus 1. And so first we want to isolate t, but in these cases, you want to think about how this relates to the trig identity, right? And so first you would want to divide by 2. So you get cosine of t equals x over 2. Now over here, take note that it's important to notice that this t minus 1 is not in parentheses. So therefore, the -1 you could be considered like outside of the sign of, it's like the parentheses would be considered on this. Like the sign is being applied to only the t, not to the 1, because there's no parentheses grouping all of that together. So you would want to go ahead and move that over first. And then you would divide by 4. So you get sine of t equals y plus 1 over 4. Okay. And then when you have the cosine and the sine isolated, if you remember the trig identity, anybody remember the trig identity that we use to set this up? Anybody remember what trig identity we use to convert that to rectangular form? No? Okay, it's all right. It's not. It's cosine squared of theta plus sine squared of theta equals 1. That was a trig identity we learned. And then we use substitution. So because cosine is equal to x over 2, we can replace this with x over 2 squared. And then because sine of theta equals y squared over 4, or y plus 1 over 4, we can replace that with y plus 1 over 4 squared. And then this is squared. And then we simplify that. So this is x squared over 2 squared, which is 4 there. And then we're going to square this all over here. Oh, this is plus right here. And you want to take note that you're going to leave this in parentheses. And you're going to square the bottom, be 16. So you leave it in parentheses because you want it in standard form of a ellipse. And that equals 1. And then this was the equation of the ellipse. And so when we have cosine and sine within the parametric equations, then it's going to create a ellipse. And that's how you get the equation there. All right. Any questions? All right. So that is the lesson on converting parametrics from parametric form to rectangular form. Where we're at next is so we just did, this was here, so we just did this. Tomorrow's office hours. If you have any questions, then Friday no class. Next week we'll do the situation problems like the baseball being hit example, talk about that, and then move on to polar. So next week is a full week. We have 4 lessons next week. Then Zoom office hours. Your practice is due tomorrow, which is Thursday, at 4:20. Remember, I'm gonna pick 3 more at random for practices. And on the practice, there's a typo on the last question. So just cross out the last question, the very last question on this practice. You can cross that out. Okay. Any last minute questions, comments, concerns?